Okay, so hopefully you've worked sample problems 1 through 3. And I'll just go ahead and walk you through the solutions here through each of these problems. Now, I want you to pay attention closely to the fact that we're talking about what types of solutions you should finish with. And so this is going to be a little bit topic of a later video. So just notice what we're dealing with on each one of those for right now. So in each of these problems, the first thing that you need to do is put them in standard form. And so we have to get this 35 over to the left side. So 3x squared plus 8x minus 35 equals to 0. And then I can say that a is equal to 3, b is equal to 8, and c is equal to negative 35. And this will help me set up my quadratic formula. And so I'm going to simply plug in, and this is again important. This is preset to be the two solutions, so it must say x equals. If you work a quadratic formula problem on the test, you cannot just start with the negative b. It must be x equals, so pay attention to that. So I'm going to say negative b, which is 8 in this case, plus or minus, because we need two solutions, square root of b squared minus 4 times a times c, all over 2 times a. Now, we've set everything inside the quadratic formula, and this becomes just a simple order of operations calculation, and so your calculator will do this for you quite effectively. So hopefully you've worked down the parts. I'm going to go ahead and move into the final answer. If we do this, we get negative 8 plus or minus the square root of 484, which actually ends up being a perfect square of 22, all divided by 6. Now, this is a unique situation where the radical was actually a perfect square, and we have real numbers here that can be combined together. So we have like terms with the negative 8 and the 22. And so in this situation, we actually need to break up the plus or minus and work on both of them individually. So I'm going to say x equals negative 8 plus 22 divided by 6, or x can equal negative 8 minus 22 divided by 6. And then I can get my two solutions for each of these. And so of course we need to reduce any fractions, and then x can also equal to negative 5. So x is going to be 7/3 or negative 5. And so that's how we would use a quadratic formula. Alright, let's look at sample 2. Alright, again, we have kind of a crazy equation that's been given to us. So the first thing we really need to do is to get it set equal to 0. Now, what I'm going to choose to do this time is move everything from the left over to the right, since I already have my 2x squared over there. And when I do that, I get 0 equals to 2x squared. And make sure you write this in standard form. Minus 12x plus 18. Now, it doesn't matter if the equals to 0 is on the left or the right, as long as you got it in standard form equaling to 0. And of course, I can identify my a as being 2, my b as being negative 12, or my c as being 18. However, if I want to make life a little bit easier, what I can do with this particular problem is I can actually divide all parts by 2. And if you recognize that right off the bat, you will then narrow this down to x squared minus 6x plus 9 equals to 0. And hopefully this will give you a clear view that, you know what, this can actually be factored. This is x minus 3, x minus 3, x minus 3 equals to 0, or x minus 3 equals to 0, so x is equal to 3. And you notice we have one real solution. So notice, this was a perfect square trinomial. We only had one real solution. Now, if I did want to go forward with working quadratic formula, I could have done that simply by plugging in my values here. Negative 12 plus or minus the square root of negative 12. Make sure you squared minus 4 times a times c all over 2 times a, and that's going to leave you with excuse me, 12 plus or minus the square root of 0 over 4, which is going to be 12 over 4. And so then you're just going to get simply x equals to 3 in the same way that you did with the perfect square trinomial. So that's a unique situation that you'll see from time to time. All right, and lastly, we'll do sample problem number 3. We'll start by moving it to standard form. Now in this particular case we have a leading coefficient that's a -1, and you can keep it that way. Standard form should actually be in a positive leading coefficient, but it's not going to affect your numbers, or it shouldn't affect your numbers as you go through this. So if you want to do a equals to 1, b equals, -1, b equals to 2, and c equals to -2, and we can plug that into the quadratic formula. -2 plus or minus the square root of 2 squared minus 4 times -1 times -2 all over 2 times -1. If I work through that calculation, I should get this as being 4 minus 8 over -2. That's going to lead me to this, plus or minus the square root of -4, which we know is going to give us imaginary numbers. Now, if I break this up, or actually if I continue this, I'm going to get -2 plus or minus, 2i all over -2. And then I can actually break this up, and the 2, or the -2, is a common denominator to both. So that's actually going to be 1 plus or minus 2i. And that's going to give us our final answer.